Hi everyone, this is Babaiah, Assistant Professor of EC Department from MLR Hyderabad. Today I am going to explain about the type number of the system or type number of the control system. Previously we discussed about the order of the system and what are the examples of the order of the system from the given transfer function, how to calculate the order of the any system we observed from the previous session. But today's session we are going to explain, just I am going to explain, or we are going to see the how to calculate the type number of the system. Now I am going to explain type number of the system. Here just observe the today overview of the today session. Just to type number of the system or some of the examples of the type number of the system, and also comparison of order and type number of the any control system, how to calculate the order and type number of the given transfer function of any control system. Now we are going to observe all these. Right, coming to the first one is type number of the system. Generally type number of the system is nothing but the number of poles present at the origin. Simply we say that the type number system is number of poles present at origin. Number of poles present at origin is known as the type number of the system. Simply right here observe the type number is specified for loop transfer function, that is g of s into h of s is nothing but the loop transfer function, and the number of poles of any loop transfer function lying at the origin decides by the type number of the system. See here, number of poles of loop transfer function g of s and h of s, that is the loop transfer function. The number of poles of the origin or lying at the origin decides the type number of the system. Any system type number can be decided by the number of poles present at the origin. Simply, number of poles present at the origin is nothing but the type number of the system. In general, if n is the number of poles at origin, then the type number is n. Simply, if n number of poles present at the origin, then we say the type number of the control system is n. Right here, coming to, I am going to consider the polynomial equation, that is the previous equation in order equation. Just here observe, the loop transfer function can be expressed as ratio of two polynomials. The transfer function is here p of s by q of s, or k is the constant here. P of s is nothing but the numerator polynomial, and q of s is nothing but the denominator polynomial. K is here constant. Already we know that by using the factorization method we got the poles are in numerator part s plus z1, s plus z2, s plus z3 and so on. Here s power of n into s plus p1, s plus p2, s plus p3 and so on. This is the equation of loop transfer function with the ratio of two polynomial equations. One is the numerator polynomial equation, this one, and denominator polynomial equation, the second one. Here this is the denominator and this is the numerator polynomial. Here where the z1, z2, z3 and so on, all these are the zeros of the given transfer function, where p1, p2, p3 and so on, all the pn up to, all these are the poles of transfer function, where k is the constant and where n is nothing but here s power of n is there, right? N, capital N, that is nothing but the poles, number of poles present at the origin only. Number of poles present at the origin. Number of poles present at origin. Number of poles present at the origin. Right. All these terms. Next here, the value of n in denominator polynomial. Here the value of n in denominator polynomial, this one here value capital N, this is indicates the s power of n is there, So this n is indicates the number of poles present at the origin, and this n indicates the type number of the system. Here observe, n is the denominator polynomial of loop transfer function that decides the type number of the system. If for example I am going to write s power of n in denominator polynomial, here n equals to 0, n equals to 0, in place of here n equals to 0 substituting s power of 0, so 0 type number is 0 system, type 0 system. Here next, if we are going to substitute n equals to 1, then the system is type 1 system. Like that, n equals to 2 or n equals to 3 and 4 and so on. When we are going to substitute n equals to some number, that number indicates the type number of the system. That is the type number system. Simply we say the type number of the system is, simple definition is the number of poles present at the origin. That indicates the number of, that indicates the type number of the system. Type number of any control system indicates the by number of poles present at the origin only. Here, if I am going to substitute n equals to 2, then the system is type 2. If you are going to substitute n equals to 3, then the system type number is 3. Like that, we are going to substitute the value in place of n. Here n s power of n, here n is indicates the, here denominator polynomial q of s equals to s power of n into s plus p1 and s plus p2, s plus p3 and so on. This is the denominator polynomial. This is the denominator polynomial in place of n, or else it n indicates the type number of the type number of control system or type number of the system it indicates. If you are going to in place of n 0 substitute, the system is going to be type 0 system, and n equals to 1 the type 1 system, 2 n equals to 2 type 2 system. Like that, we are going to determine the, or we are going to observe the type 0 or type 1 or type 2 type 3 systems and so on. Like that, we are going to decide the type number is belongs to 0 or 1 or 2 or 3 based on the number of poles present at the origin only. Number of poles present at origin only. If here number of poles present at origin is this one only, S term only, single S term is indicates here number of poles present at origin. But here remaining poles are just S equals to minus P1, some value S equals to minus P1, that one value is P1 pole. The S value is P1 pole, right? It is not a origin. This one only origin pole, right? S power of n is the origin pole that indicates the, or it gives the information about the type number of the system. Here next, some of the examples of type number of the systems. Just I am going to consider one example. Our loop transfer function g of s into h of s. G of s into h of s is equals to some s into s plus 1 or else s plus 1 divided by s into s plus 2 and s plus 3, like that. S plus 1 divided by s into s plus 2, s plus 3. Here observe, s power of, here one value is there, s power of 1. So s power of 1 is, s term is there. One pole present at the origin. One pole present at origin, right? One pole present at origin. One pole present at origin, that means the given system is the present at origin. That means the given system is the type number system. Simply we are going to decide the type 1 system. This is the type 1 system. Like that, the second example, just I am going to consider here g of s into h of s. This is the loop transfer function that is equals to, I am going to consider one example, s plus 3 divided by s square into s plus 2 and s plus 5. From this example, just observe what is the type number here. The type number indicates the number of poles present at the origin. How many poles present here? S square, two terms, or two poles are present at the origin. Then we call it as the type number is 2. So type 2 system. Type 2 system. The next example, just I am going to consider g of s into h of s is equals to s plus 5 divided by s cube into s plus 2 into s plus 4. S plus 4. This is the number of poles present at 3, right? So type number is 3. Type number is 3. Type 3 system. Like that we are going to calculate the type number of any system. Right here, one more example, just observe. I am going to just write here g of s into h of s is equals to s into s plus 2 divided by s into s plus 3 s plus 4. Just identify this one is the system is comes under the which type number system. Just observe s into s plus 2 s into s plus 3 s plus 4. Here s both get cancelled. S plus 2 divided by s plus 3 s plus 4. So is there any poles are present at origin? No, in this condition there is no poles present at origin. Then type number is directly simply the type of 0 system, because of there is no s terms, s power of 0, that is nothing but 1. So here type 0 system, it is comes under the type 0 system. Like that we are going to determine the type number of the system. Simple, right? Next, coming to the some comparisons of order and type number for the some examples. Now I am going to consider some examples from that, just to calculate the order of the system and type number of the system. Just a comparison. Here order of the system can be determined by using the open loop control systems as well as closed loop control systems. Right here type number system is loop transfer function. Okay, loop transfer function systems, or as here if I am going to consider the, for example, in loop transfer function, is there any unity feedback system? Is there h of s is going to be 1? Then directly g of s, open loop transfer function, open loop as well as closed loop. So that's why the type order of the system can be determined by using open loop as well as closed loop, because of for the unity feedback system, that is h of s equals to 1 condition also, we are going to calculate the order of the system. Here type number, simply order and type number can be calculated. For order is open loop as well as closed loop, and type number is the in closed loop transfer function. Closed loop system loop transfer function only. In closed loop only we are going to get the closed loop system only, we are going to get the loop transfer function, that is the g of s into h of s. G of s into h of s, this is the loop transfer function. Just observe, if we are having any closed loop control system, c of s divided by r of s equals to g of s divided by 1 plus g of s into h of s. In this condition, the loop transfer function g of s into h of s is nothing but the loop transfer function. This is g of s is the open loop transfer function, and g of s into h of s is the loop transfer function. This complete value is nothing but the closed loop transfer function. These three terms in a single closed loop transfer function. Like, okay, next I am going to just consider some examples, and we are going to determine the type number system as well as order of the system. Type number and order of the system. The example, for example, first one, g of s equals to, for unity feedback here, h of s equals to, obviously h of s equals to 1, or else g of s into h of s is equals to h of s into g of s is equals to, just to calculate the s plus 2 divided by s into s plus 2, s plus 3 and s plus 4. Okay, here just to find the or compare the order and type number system and order given system. How to calculate the order of the system and type number of the system from the same example. Here this example, just to observe, order is nothing but what? Order of the system is, and type number of the system, type number of the system. Here order is nothing but maximum power of s. Here how many s terms are there? 1 2 3, 3. So s cube, so 3. So order is 3, maximum power is 3. And type number system, type number is determined of the any system by using the number of poles present at origin. Number of poles present at origin is only one pole, so one pole is nothing but here type number is 1, type number system is 1. This example. Next, coming to the second example, g of s into h of s, g of s into h of s equals to s plus 5 divided by s square into s plus 2 into s plus 9. For example, the order of this system is, order is s square, 1 s cube and one more s power of 4. So order is 4, and type number is, number of poles presented 2. So type number is 2. Like that we are going to determine the order and type number of the any system. Next example, I am going to just consider one more example. Here g of s and h of s is equals to s plus 2 and s plus 3 s cube into s plus 2 into s plus 5 s plus 5 and s plus 6. Here order is maximum power, right? Maximum power s power of 3. Here see, observe, numerator polynomial s plus 2 one term and denominator s plus 2 both are same, so this term is going to be get cancelled. After that, calculate s plus 3 divided by s cube, s plus 5, s plus 6. The maximum power s cube and one more s power of 4, one more is s power of 5. So order is nothing but 5, fifth order system. And also here s cube, and also how many poles present at origin, type number system, s power of 3. So 3 poles present at origin, so type number is 3. Like that we are going to calculate the type number and order of the system. Order can be determined by using the open loop control systems, as well as open loop control system, as well as closed loop control system. Closed loop control system and open loop control system. Here type number is the closed loop control system, that is the loop transfer function. Just we are going to consider loop transfer function only. This is the difference as or else a comparison of open order and type number, and some of the examples from the same example, how to calculate the order and type number of the system, and what is the meaning of type number of the system, and what are the examples of type number of the system, and some of the examples of type number of the system, and comparison of type number and order of the any control system. All these are we learn from the today's session. I hope you understood every point, I think. Thank you all.